Continuing our discussion of hybridization, bond angles, and geometry, we have our next activity. And before I move on, I'm going to make sure I put my lone pairs on because they do contribute to geometry. Just the nature of each atom. Oh, I got fluorine and bromine, although those atoms don't have what we call geometry because they're on the end. There you go, just a good practice. Unless it's a Lewis structure, you don't have to show lone pairs, but you do know they're there because you do know the nature of the atoms, right? Okay, so we're going to count sigma bonds and lone pairs. You remember that's the whole secret for hybridization. So I'm pointing to carbon with 4 sigma. 4 sigma 0 LP. That's sp3. That's I.
sp3 with
geometry name tetrahedral. Bond angle.
109.
Yeah, the tetrahedral angle. And you don't have to ever shrink that number or make it a little bigger. I know you learned about that with ammonia and water. The angles get slightly shrunken down because lone pair bonding repulsions are more than bonding repulsions. You learned all that stuff, forget about it. You don't need it. We need to know ballpark. So that's why I wasn't too upset when he said 109. Probably give it to him on the test because we're in the ballpark anyway. There's other factors like sizes of atoms. If you start squishing things together, they push back when they get bigger. So for organic chemistry, that thing you were doing with water that says it went down to 104.5, well, you replace those H's with C's, now it bounces back to pretty close to 109.5. So that's why we're not going to vary from our 3 angles that we need to know for our 3 geometry, for our 3 hybridizations, right? Quick review, sp3, what's your bond angle? 109.5. sp2, what's your bond angle? 120. sp, we didn't do an example yet, but that's the third one. 180. There you go.
The C is
Any atom with 4 sigma bonds, or 3 sigma bonds and a lone pair, or 2 sigma bonds and 2 lone pairs is sp3. And the bond angle will be 109.5. Okay. Now the geometry name changes when one of those things is a lone pair. Yeah, because we don't see the lone pair, but we do see the effect of it because it repels electrons. Otherwise, things would be flat when they're not. This one's not flat. All right, what do we got? We have 3 sigma plus 1 LP. Lone pair. That's 4. Answer sp3 again. Answer 109.5 again. Please don't say tetrahedral again. This one is pyramidal. You could say trigonal pyramidal. You could say it. But you don't have to. We have no other kind of we don't have a square pyramidal in organic chemistry, so let's not make a distinction when we don't have one. Yeah. Oh, you're going to find a video, one of those introductory, probably in the first 12 videos on the list. One of them will be about geometry. And then it'll just slowly go through. If you're lost right now, those videos are about getting you ready before class. Because we're just going straight to questions. That's all that really counts, right? But you can be overwhelmed if you think you just come into class without any background. Oh, I don't remember doing that. No, because I didn't. I did that during COVID, so we can just apply ourselves now. Better use of your time. Okay, what do we got for the next one? 2 sigmas, 2 lone pairs?
This is over here. This is the 180 on that.
Uh-oh. Uh-oh. Now that would be for an sp hybrid, not for an sp3. I got 4 things right there. 2 sigmas, 2 lone pairs. That's 4 fingers.
Oh, yeah.
sp3 is your hybridization. Geometry is not tetrahedral. not pyramidal. But, you know, you started with a tetrahedron. The atoms still think that it's a tetrahedron, but the lone pairs are in two of the corners. So all you describe is the atoms, not the lone pairs. They push the atoms down, it's a bent. It's bent. If it's sp3, the angle's always the same. Yeah. Okay. And going to D. We got 3 sigmas, sorry. Plus 0 LP. Can I count the sigmas? There's always 1 sigma between any 2 atoms. 1, 2, 3. No lone pairs. That second bond does not contribute to geometry. It's a pi. Pi's don't contribute. So that is sp2. Answer I is sp2. Just to be clear. Just to be clear. Answer I is sp2. What about answer II? What's the name of the geometry with them? The atoms are on the outside, form a triangle. Trigonal planar. I laugh again. I didn't explain why I laughed the first time on the previous video. Why do I laugh when I say trigonal planar? Draw me a triangle that's not planar. You will be busy for the rest of your life doing nothing. Okay. All right. What about the angle for sp2? 120. Nice. All right. If I put 3 things under each of these letters, you realize they're answering I, and I. E. I'm never going to stop counting. 2 sigma plus 2 LP. So the first thing is sp3. Let's put it under the E. And hey, we had one of those. We already had one. 2 sigma, 2 lone pair, sp3. Bent. sp3 is always 109.5. F. 2 sigma, 0 LP. Our first SP. Congratulations. Right? 2 fingers. Name is always what? Linear. Oops. Wish I could spell. What's your angle? 180. G is 3 sigmas. Don't be fooled by that H there. There's a bond to it, right? Yeah, 3 sigmas plus 0 LP. G is sp2, and it's trigonal planar. Can I go trig planar? Since I don't like the planar anyway. Well, it's short, trig. sp2 trig planar, and the angle 1. Sorry? I got a sigma bond to an H, a sigma bond to a C, and a sigma bond to an N. Just because they're written beside each other doesn't mean there's not a sigma bond. There has to be a sigma bond. Yeah. And what about the H? That's got 2 sigmas and 1 lone pair. 2 sigma plus 1 LP. And I got a typewriter. Nice. Free of charge. So the answer for H would be sp2 again. Don't call it trigonal planar because there's a lone pair. But do call it 120 because it's sp2. It's bent. Oh, there's 2 bents. sp2 with a lone pair and sp3 with a lone pair called bent. The only difference between the 2 is the angle. 120s are less bent. How's that? Still a bend. I think we got them all. We didn't do functional groups. I apologize. A is really not, it's functional groupless. Yeah, it's got halogens on it. You can say that. That's fine. But we don't do that functional group. We'll start with B. Do you remember what I said about this functional group? Primary amine based on the fact. This is the answer to question 2. We'll do in orange. Orange. Primary mean. Now this one, this C has one bond to C equals primary alcohol. Primary alcohol. We did not look at the oxygen like we did here. Here's a reminder. N has one bond to C, is why it's primary. Alcohols don't look at the O. Do not look at the O. Look at the C attached to the O. Classify it. How many bonds to C does this C have? 1. Primary.
So what is it, the H3 OH?
0 dairy is called 0 degree. Nobody calls it that. Instead, they call it methyl. It's a less than a primary. Less than primary. Very good question.
The first one, what is that methyl?
No, that's an asshole, but that's looking way ahead. Don't confuse my students. It's okay. This here is a COC functional group. There's 2 of those. When neither of the carbons has a double bond to oxygen, it's called an ether. And we don't put numbers in front of ether. Now, if one of those 2 carbons attached to the O was a carbonyl, do you remember what a carbonyl was? A C with 2 bonds to O. If one of those C's was a carbonyl, we'd call it an ester. E-S-T-E-R. You're going to read about the functional groups because your goal this weekend, you got to get through chapter 1 reading wise. All right. And we're up here. Oh, look at this. A COC with one of the C's is a carbonyl. C double bond to O is not a functional group. Carbonyl is not the name of a functional group, but it's a part of half of our functional groups in chapter 1. So it's not an ether. It was the other one. What was it? Ester. You can say carboxylic ester. There are many types of esters, but when it's a C double bond to O in the ester, it's a carboxylic ester. But if you leave out the carboxylic, it's understood to be a carboxylic ester. Are we clear? So just make sure you know. Ester's fine. F is a C with a triple bond to C. That's called an alkyne. Alkyne and a C double bond to N. Oh, that's a Chem 242 functional group. So it would be like a bonus. It's not in chapter 1. It's called an imine. So imines are like amines, right? Except there's a double bond between the C and the N. It's an imine. My favorite example of imines are, you've got an imine in your eye. When retinal combines with a protein in your eye called opsin, it forms an imine bond between the 2. And now that thing absorbs light and changes the shape of a protein. And an electrical signal sent to your brain. And it says, I see the light. It's very cool stuff. And I think we got them all. Okay, Esther, yeah. Now we're done with that.
So the mean name comes from a nitrogen bonded to a
If
carbon.
you see MINE at the end, you know there's nitrogen. Or, yeah. And if you see MIDE, you know there's nitrogen with a COO attached. And I think that's going to be it for today. What I'm going to do, though,